Hi, welcome to the 11th lesson on differentiation, looking at derived graphs. Okay, so derived graphs are looking at sketching a graph of the gradients, what's going on with the gradients of a curve. Okay, so our intention is to be able to use or sketch the derived function. You need to be able to do four things here: being able to identify the gradient along the original curve, whether it's positive, it's zero, it's negative. Where the gradient is zero, where it's a stationary point, your derived graph looking at the gradient has to be roots therefore, because it will be zero. Being able to shade in along the derived graph where the gradient is positive or negative, and then being able to sketch a curve through those shaded areas. Okay, so I'm going to show you two examples here. First one here, being able to sketch the graph of that derived function of that graph there. Okay, so looking at that, there is a graph. Four things you need to be able to do. Firstly is being able to identify whereabouts what the gradient is doing along this original graph. So up until that first stationary point, we know that it's positive that whole way. That's an increasing function. The gradient there is going up the way. At the stationary point, at 1, it's 0. Then it's gone down the way. At this stationary point here, it's also 0. And then it's increasing. Oops, sorry, I went a bit haywire there. So it's positive along there. Okay, now, next thing you need to do is, on that derived graph, at the stationary point, you know the gradient is 0. So on your derived graph, the graph has to go through there. It has to go through the 0 at these points. Okay, so it's at 3 and at 1. You know the gradient is 0 because it's a stationary point. So your derived graph, the graph of the gradients, has to go through there. Prior to 1, it's positive. So that means it's going to have to go through somewhere above the x-axis, because the gradients are going to be 1, 2, 3, all positive numbers. So it's going to be up there. In between 1 and 3 it's negative, so it's going to be below the x-axis because the gradients will have a negative value. And then after 3 it's going to be positive again. Okay, so all you need to do now to draw a sketch of your derived graph is take your pen and go through these shaded areas. So it's going to come down through zeros, come down here, turn, and come back through. Okay, sorry, actually I went right through that point there. Okay, make sure your sketch has 1 and 3, labelling clearly as your roots, and that's going to be there. Okay, that makes perfect sense, because if you differentiate a cubic function, your power comes down, your 3 comes down, your power becomes a squared, so you end up with a parabola. Okay, so this is the graph of f dash x. Okay, now if you can follow that method, identifying what the gradient is doing, bringing your roots down, shading in, and then following your line through it, it's just the same thing you're doing regardless of how complicated the graph is. You're just kind of making it, you're just doing more bits basically. Okay, so there, if we look at this graph, okay, same idea. We want to identify the gradient and do the derived graphs for this. Okay, so again, looking at it, prior to that first stationary point of -2, it's rubbish, absolute nonsense. Okay, prior to that, it's going down the way, so it's negative that whole way. At the point -2, the gradient is 0. It is then positive, in between, at 2, it's 0, negative, 0, positive. Okay, so we bring our stationary points down. That's got to be a 0, because it's gradient 0 at that point. That's got to be a 0. And that's got to be a 0. Okay, so -2, 2, and 7 are where your roots are. Prior to -2, it's negative, so it's got to be down below the x-axis. Between -2 and 2, it's positive, so it's got to be above. Between 2 and 7, it's got to be below. And then after 7, it's got to be above. Okay, so just the same idea, you're just doing more of them. And then the last bit, you've just got to draw a line that goes through there, through the 0 at -2, turns up in the positive, comes back to hit the 0, and then comes back through 7 up there. So at -2, 2, and 7, that's where your roots are, and that's a sketch of your derived graph, f dash x. Okay, now the only thing to be slightly careful of that I'm not showing you here is a point of inflection. A point of inflection will be positive, go back to 0, and then positive again, so it'll come down and touch the x-axis. Okay, but being able to do those four things will mean that you can always sketch a derived graph. Okay, being able to identify the gradient along the original curve, be able to make the stationary points your roots in your derived graphs, shade in whether the gradient's positive or negative, and then sketch that curve through those areas. Okay, now that's your derived graphs. Thank you.